In this session, we are going to continue with the series of videos that we are doing on homogeneous differential equation. We'll take the differential equation, we'll try to show that the given differential equation is a homogeneous differential equation, and we are going to solve that homogeneous differential equation. Hi, I'm Syed. Welcome to my channel Educate with Syed. Let's get started. The question is, show that the differential equation x dy by dx minus y plus x sine of y by x is equals to 0 is homogeneous, and solve it. Now, to show that this given equation is a homogeneous differential equation, first we need to identify the function and take that function and show that the given function is a homogeneous function. If the function is a homogeneous function, then the given differential equation will be a homogeneous differential equation. For that, let us try to rewrite this given differential equation in the form of dy by dx is equals to f of x comma y. So we need to rewrite this differential equation in the form of dy by dx is equals to f of x comma y. So let us first identify this function f of x comma y from this given differential equation. So rewriting the given differential equation, so the the differential equation is rewritten in this form x dy by dx. We shall retain this as it is, send these two values on the other side. This minus of y, when it comes on the other side, it becomes plus y, and this plus x sine y by x, when it comes on the other side, it becomes minus x into sine of y by x. Cross multiply this x on the other side, we get dy by dx is equals to y minus x into sine of y by x, it is whole divided by x. Now you can split this one and divide each of the term by x. We get y by x minus x sine of y by x, it is whole divided by x. We see that this value of x and x will cancel out. So what will be left out now? Y by x minus sine of y by x. Now can you see that we have expressed the differential equation dy by dx in the form of f of x comma y. When you try to compare these two equations, the right hand side value f of x comma y is obtained. So therefore we have here the value of f of x comma y to be equals to y by x minus sine of y by x. Now to show this function to be a homogeneous function, what we have to do is we have to replace the value of x by lambda of x and replace the value of y by lambda of y, and show that it is equals to lambda power of 0 into f of x comma y. Then we can say that this given function f of x comma y is a homogeneous function of degree 0. So let us try to show this one. For that, we need to put the value of x to be equals to lambda of x, and we have to put the value of y to be equals to lambda of y in this given function f. Let us try to replace it. F of x will be replaced by lambda of x, y will be replaced by lambda of y is equals to, here y is lambda of y divided by x is lambda of x minus sine of y is lambda of y divided by x is lambda of x. We see that this lambda values will cancel out. We are left out with y by x minus sine of y by x. So we try to check this one, is it not similar to the value of f of x comma y? This is nothing but f of x comma y. So therefore we get this value to be equals to f of x comma y. or can I rewrite this as lambda power of 0 into f of x comma y, because lambda power of 0 is 1, so I can rewrite this as lambda power of 0 into f of x comma y. So we got f of lambda x lambda y is equals to lambda power of 0 into f of x comma y. If it is in this form, then what type of function f of x comma y is? F of x comma y is a homogeneous function. F of x comma y is a homogeneous function. Homogeneous function of degree 0. So if the function is a homogeneous function, we can conclude that the differential equation, or I can write in short, the differential equation is a homogeneous differential equation. Is a homogeneous differential equation. Now once you have got a homogeneous differential equation, we need to solve this homogeneous differential equation. So what is that homogeneous differential equation? We have dy by dx is equals to y by x minus, you have sine of y by x. Let us take this differential equation as equation number 1. Now to solve this homogeneous differential equation, we have to make one substitution. To solve this differential equation, we will try to put the value of y to be equals to vx. Let us try to differentiate this one. Differentiate with respect to x. So if you try to differentiate this with respect to x, we get dy by dx is equals to, now vx is in the form of a product rule, so therefore vx is in the form of a product, therefore we will try to use the product rule over here. V into differentiation of x will be 1 plus x into differentiation of v will be dv by dx, or this is nothing but v times of 1 is v plus x into dv by dx. Now we can replace the value of dy by dx as so much in equation number 1. So equation number 1 implies dy by dx is nothing but v plus x into dv by dx is equals to, y value is vx divided by x minus sine of y is what? Y is vx, so vx by x. We see that this x value will cancel out, we are left out with v plus x into dv by dx is equals to this value v as it is minus sine of v. However, we can see that this value of v and v on both the sides will cancel out. We will be left out with x into dv by dx will be equals to minus sine of v. Now let us try to separate the variables. We will try to retain dv as it is, send this sine v on the other side, it becomes divided by sine of v is equals to, so try to cross multiply the dx on the other side, we get dx by this x. Now we see that this is in the variable separable form, therefore you can integrate on both the sides. So integrating we get dv by sine of v is equals to, it is integral of dx by x. Let us try to integrate this one. Integral of dv by sine v, we can rewrite this as integral of 1 by sine is nothing but cosecant, it will be so cosecant of v into dv is equals to, so integral of dx by x as it is. Now we can integrate on both the sides. Integral of cosecant of v is nothing but log of mod cosecant of v minus cot of v is equals to, integral of dx by x is what? Log of mod of x, plus we need to add the constant of integration because both the integral values that we have are in terms of log, therefore since both the solution values that we have got are in terms of log, therefore we'll try to add the constant of integration as log of c. On the right hand side, this is in the form of log m plus log n, which can be written in the form of log m into n, that is c times of mod of x. Left hand side will remain the same. So if I try to equate, since both side log is there, so in that case you will just be left out with cosecant of v minus cot of v will be equals to c times of x. So log will be eliminated. But what is the value of v we have? Since we know that initially we have taken y value to be equals to v times of x. So we have taken over here the value of y to be equals to v times of x. So from here I can get the value of v. So v value will be equals to, cross multiply, will be getting y by x. So what is the value of v we have? V value will be y by x. So just plug in this value of v to be equals to y by x over here, but the value of v is equals to y by x. So let us substitute over here. We get cosecant of y by x minus cot of y by x is equals to, it is c times of x. That is the required solution we have. So that's all I have for today. If you like my videos, please subscribe to my channel. Thank you.